you remember the numbers that belong to these number sets? Natural or counting numbers? Can you give me an example? Can you think of an example? Counting numbers. Numbers we use to count. 1. How about another one? 2, 3. Fractions? No. 0? No, not for the counting numbers. So the counting numbers are all represented. They start at 1 and go up by ones. 1, 2, 3, ... How about the whole numbers? Very close to the counting numbers, except there's one additional number, 0. So the whole numbers start at 0 and go up by ones. And that's how we can show it using fancy math notation. How about integers? Include the negatives. Any fractions or decimals yet? No. So for the integers, we actually use Z because we use I for something else. So we have to write it like this. So we would start at 0, go up by ones forever, but then also go down by ones forever, like so. Rational numbers. I tried to beat this into my class last year, but whenever you hear the word rational in math, you should think of a word, fraction. They mean the same thing. A rational number, which we call Q, because we use R for something else, we can't really list them. You can't, like, what's the next fraction after 1/2, right? You can't list them like we can the previous number sets. So we just sort of have to describe it. Any number that can be written as a fraction. As long as the denominator doesn't equal 0, because we can never divide by 0. So let's think of some examples. Well, if it can be written as a fraction, then I guess any fraction you give me is going to be a rational number. So give me a fraction. 1/2. Could be negative, negative 2/3. Okay. What other form can we write fractions as? Decimals. So that means decimals are also. So like 2.7, negative 0.5, repeating, because that can be written as a fraction. So can negative 0.5. Those are two different numbers. Okay. So fractions, decimals, positive and negative. What about all the numbers above? Are they also rational numbers? Like, is the number 7 a rational number? Why? Because you can write it as the fraction 7/1. So all of the above or I'll just say all natural whole and integers. Because all you can write every single one of those as a fraction by just tossing it over 1. Okay? Well, if that's the meaning of a rational number, what do you think the meaning of an irrational number is? Rational numbers can't be written as a fraction. And we use Q with a bar. And not be written, thank you, as a fraction. What do you think? There must be examples. You can write the fraction, you can write 0 as 0 over 1. So 0 is a rational number. Jamie? That number doesn't even exist. Good thinking, but that number doesn't even exist. There is one number that you guys have been working with, a number that never, like if it's in decimal form, it never repeats or never ends. Pi. Is definitely an irrational number. Because if it never repeats and never ends, you can't write it as a fraction. There are also a whole bunch of others. Any square root of a non-perfect square so like the square root of 0 is 0. That means it's rational. The square root of 1 is 1. That means it's also rational because you can write that as a fraction. The square root of 2, however, is 1 point something. And that decimal goes on forever, never repeats, never ends. So the square root of 2 would be irrational. So would the square root of 3, but not the square root of 4, because that's 2. So as long as it's a non-perfect square, it's also irrational. You could do the same thing with the cubes. As long as you can take the cube root of any non-perfect cube. So the cube root of 0 is 0, the cube root of 1 is 1, but the cube root of 2 is 1 point something again. And that decimal goes on forever, never repeats, never ends. Okay? We did something like this last year. When you put all those groups together, they are called the real numbers. This is where we use R. So imagine a diagram that shows all the number sets we just talked about. So all of the numbers are in the big rectangle. Real. Those numbers are either rational, you can write them as fractions, or you can't. So the rational numbers would be the big oval. Yeah, come on in. Thank you. The rational numbers would be the big oval, but outside the big oval and inside the rectangle would be the irrational numbers. Every integer is also a rational number. So the integers would go inside the rational numbers. Every whole number is an integer, so all the whole numbers would go inside the integers. Oh, sorry, that's Z, not I. And the natural numbers, well, the natural numbers, they're also whole numbers, they're also integers, they're also rational numbers, they're also real numbers. There is a group of numbers outside the real numbers, but that's sort of advanced mathematics. They're called imaginary numbers. Okay, so just a couple of examples. First one, rational or irrational? Irrational. I'm not going to ask you to write it down, but why is it irrational? Don't overthink this, because it can be written as a fraction, because it is. Square root of 14. Rational? Can you take the square root of 14? Is it a perfect square? No, it's going to be 3 point something. And that decimal is going to go on forever, never repeat, never end. So it is irrational. Because it is a non-perfect square. How about this last one, cube root of 27? Why? Because it equals 3, which can be written as 3 over 1, a fraction. So it is rational, correct. Well done. Okay. So you should be able to identify numbers as rational or irrational. The last question I have for you, how to put them in order. And we're going to try this without a calculator, okay? Which means we're going to approximate each one. Is there one of these 4 that you actually can evaluate right now? Square root of 9. Square root of 9 is 3. What's the square root of 18? Well, we can't take it exactly, can we? Don't use a calculator, because we want to approximate it. Yes, it would be between 4 and 5, or 4 point something. That's all we need. We don't need the exact answer. Why is it 4 point something? Because the square root of 16 is 4. And since this is a little higher, the answer is going to be a little higher. But it's not going to be up to 5. So it's going to be, let's just say 4 point something. I know that doesn't sound very mathy. Remember, we're just ordering these. That's the purpose of the question. We're not evaluating each one exactly. If we did, well, then obviously we'd have to do something else. Okay, so we got these. So obviously, this is lower than this. How about the other two? Cube root of 13. What's a number below 13 that you can take the cube root of exactly? Not 9. 8. The cube root of 8 is 2. The cube root of 27 is 3. So doesn't this answer have to be between 2 and 3? So it's 2 point something. All right. How about the cube root of negative 5? Can you think of a cube root of a negative number that you can take exactly? What's the cube root of 8? What's the cube root of negative 8? Negative 2. What's the cube root of negative 27? So the cube root of any negative number will always be not itself, negative. It'll be negative. And that's all I need to know. I don't need to know the exact answer. All I need to know is that it's going to be negative. And if it's negative, that means this must be the smallest one. So the order is the cube root of negative, smallest to largest? Yes, least to greatest. So that's the smallest because it's negative. This is next because it's 2 point something. This is next because it's 3. And this is the biggest because it's 4 point something. And that's how we would do it. Okay? We only needed to approximate. I mean, I suppose you could use a calculator, punch them in, and find them. Works much the same way. But it helps to have some good estimation skills. Okay,